What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A Plus 1201 certification exam. So let's get into it. You decided to set up your own small office or home office network, or maybe you're just trying to figure out what the heck is going on behind the blinking lights on your router. Either way, this video is for you. So I'm going to walk you through the key components of setting up a basic wired and wireless SOHO network with a special focus on internet protocol or IP addressing. And don't worry, I'm going to keep things practical and beginner friendly. And by the end, you'll not only understand terms like IP version 4, DHCP, and APIPA, but you'll also know how to put them into action. So let's go. All right, so first things first. Why are SOHO networks even a thing? Well, in today's connected world, almost every home and small business needs internet access, whether it's for remote work, online gaming, running a small business, or streaming videos on every screen in the house. A properly configured network is essential. And SOHO networks, they typically consist of a modem to connect to your ISP or your internet service provider, a router to manage traffic between devices and the internet, switches for wired connections to multiple devices, wireless access points, which are sometimes built into the routers for Wi-Fi access, and devices like computers, printers, smart TVs, and much more. So now that we understand all of that, let's go ahead and get into the networking portion, starting with IP addressing. All right, so exactly what is IP addressing? So imagine that you're at a crowded coffee shop and you want to send a note to your friend. But unless you know exactly where they are sitting, well, you're not going to be able to send that note. And that's basically what an IP address does for computers. It gives each one a unique seat or address so they can communicate. Now, IP addressing, this is how we label each device in the network so it can send and receive data. And you can think of it like a digital mailing address. And there are two major versions that you need to know. You need to know about what's called IP version 4 and IP version 6. All right, so let's talk about IP version 4. Exactly what is it? Well, IP version 4, this stands for Internet Protocol version 4, and it's been the backbone of the internet since the beginning. It uses a 32-bit address scheme, which allows for about 4.3 billion unique IP addresses. Now, that seemed like a lot at first, but with the explosion of internet-connected devices, well, we've essentially run out of IP version 4 addresses. And an IP version 4 address looks like this on your screen right here, 192.168.1.1. And each part between the dots, this is called an octet, and it can range from numbers 0 to 255. All right, so let's talk about private versus public IP version 4 addresses. So when configuring a SOHO network, it is crucial to understand the difference between private and public IP addresses. And here's essentially what a private IP version 4 address is. Well, these are used within local networks like your home or your small office, and they cannot be routed on the internet directly. So you can think of them as for internal use only. And the common private IP ranges are 10.0.0.0 all the way to 10.255.255.255. Then you got 172.16 all the way to this other number right here, 172.31, and 192.168 all the way to this number, 192.168.255.255. And basically an example of this would be your home router, which is this thing on this diagram right here. This might assign the IP address of 192.168.1.100 to a random device or your laptop in your network. Now, when it comes to public IP version 4 addresses, these are globally unique and assigned by the internet service provider. And basically, this is how your router appears to the outside world. So in this diagram right here, here's the outside world, i.e. the internet, sending signals to your modem, which sends signals to your router. And basically your public IP address is the public IP address that the internet sees. So when you're on your laptop right here, going to Google, Amazon, or whatever website you're visiting, you have a private IP address. And so you're sending requests to go visit a website over here. But when the website sends the request back to your device, it has no idea what the private IP address is of this device. Instead, it is sending all that information to the public IP address of the router. And then from there, the router goes through the process of disseminating that information to the device that actually requested to get access to that website. And the process that makes all of this happen when converting from a public IP address to a private IP address, this is called network address translation, where essentially your router converts its public IP to the private IP so that the information can get from whatever resource that you were trying to request back to the device that actually requested it. All right, next let's talk about IP version 6. So, since we're basically out of IP version 4 addresses, IP version 6 was introduced. And this uses a 128-bit address, which means we can have approximately 340 undecillion unique addresses. And undecillion is basically a number that looks like this: 3.4 times 10 to the 38th power. So, essentially, we have unlimited IP addresses. Theoretically, I'll put it that way. And an IP version 6 address looks like this very long number right here. Basically, you have 8 blocks: 1, 2, 3, 4, 5, 6, 7, 8. And each block has 16 bits apiece. So you do 16 times 8, and that gets you the magical number of 128 bits compared to the 32 bits for an IP version 4. Because if we go back to this slide over here, IP version 4, you have 4 octets. Each octet has 8 bits apiece. 8 times 4 equals 32 bits. Now, when it comes to IP version 6, this is slowly becoming more common in most modern routers. They do support it alongside IP version 4. But for basic SOHO setups, you'll most likely deal with IP version 4, at least for now. All right, so now that we've talked about the various IP address types, let's talk about how devices actually get assigned an IP address. So we have what is called static IP addressing. And basically, static IP addressing is when an administrator manually configures an IP address on the device. And so you basically go in there and tell the device, hey, you're always going to use this IP address, and it's never going to change unless the admin manually updates it. And you would use this in the case of setting IP addresses for servers so people always know where to find them, network printers, IP cameras, or any device where a consistent IP address is helpful. Now, how do you go about setting a static IP? Very easy. You go to the network settings of that device, you choose manual or static IP configuration, and then you enter the IP address, the subnet mask, the gateway, and the DNS server. An example of that will be all of this information down here: the IP address of 192.168.1.50, a subnet mask of 255.255.255.0, and the gateway of 192.168.1.1. Now, as a tip, you want to make sure that the static IP you assign is outside your router's DHCP range to avoid any conflicts. And then we have what is called dynamic IP addressing. And this means that the IP is automatically assigned by a DHCP server or usually your router. And it can change over time, but for most devices, that is totally fine. And how does this work? Well, basically, your device boots up and says, hey, I need an IP address. The router says, cool, here's the IP address of 192.168.1.105, and you can use it for 24 hours. And then the device will use it until it expires or the IP address is renewed. So dynamic addressing, this is easy, fast, and this is usually the default for most home routers because most of you all are not sitting in your house right now manually configuring IP addresses for your laptops, smartphones, smart TVs, or any other device out there that touches and interacts with the internet. All right, so let's move on to talk about APIPA. Now, exactly what the heck is APIPA? Well, APIPA, this stands for Automatic Private IP Addressing. So if your device tries to get an IP address from the DHCP, and it fails to get one, your device will automatically assign itself an IP address from this range right here, 169.254.0.0 through 169.254.255.255. What does that mean? Well, basically, your device can still talk to other devices on the same local network with an APIPA address, but your device will not be able to reach out and talk to the internet. Now, APIPA, this is a fallback mechanism, which is kind of like saying, I didn't get instructions, so I'll just do my best with what I have. So if you ever see an IP address that starts with 169.254.x.x, and the x.x represents whatever numbers are thrown up in there. But if you ever see this address on your device, that means that your DHCP server probably is not working, or there might be a cabling issue that you need to go out there and resolve. All right, next let's talk about this thing called a subnet mask. Now, you can think of a subnet mask as a filter that tells your device which addresses are on your local network and which ones are not. And the common one is 255.255.255.0. Now, what does that mean? So let's take the IP address of 192.168.1. whatever, but the 192.168.1, they represent the first 3 octets. And basically those first 3 octets represent the network. And then the last octet, that will represent the actual identification of the device that resides on that 192.168.1 network. So in this example down here, you got the IP address of 192.168.1.0/24. Well, the network portion is 192.168.1. That is the network. So think of the network as that is the apartment building number that you live in. And then the actual .1 portion, that actually represents the device that resides on that network. And you could think of that as your apartment that is inside of that apartment building. So once again, you live in the building 123 Main Street, but within that building, your apartment might be apartment 1A. And so I say all of to say, subnet masks, they basically help devices figure out if they should send traffic locally or to what is called the gateway. And speaking of gateways, so a default gateway, this is the device, usually your router, that connects your local network to the outside world or the internet. And basically your device is saying this, hey, I want to go visit google.com and it's not on my local network. So your device is going to go ask the gateway to handle it for you. Now, if your gateway is misconfigured or missing, then your device will not be able to access the internet, even if it does have a valid IP address. And for the majority of you out there listening to the sound of my voice right now, the default gateway is often the IP address of your routers. So if you're out there trying to manually configure your router as we speak, more than likely the default gateway address is 192.168.1.1, or it might be 10.0.0.1. But essentially, the default gateway, this is essentially the doorway or the gateway for your little network right here to go outside and play in the bigger world known as the World Wide Web or the internet. So this is the address right here that all of these devices have to find and locate if they want to exit your network to go communicate with YouTube, Amazon, or whatever the heck it is that you look at on the internet. All right, so let's go ahead and put all of this wonderful information together. So how do you actually apply all of this knowledge in a real world setup? Well, here's a step-by-step guide for setting up a basic wired or wireless SOHO network. So the first thing you want to do is you want to connect your modem in your router. So you want to plug your modem into the wall using your coaxial or fiber optic line, whichever internet service that you're paying for. And then you want to connect the modem to your router's wide area network or internal port. After that, you want to access the router's admin page, and you can do this by connecting to your router via Ethernet or Wi-Fi. And basically, you either plug in an Ethernet cable or you go on Wi-Fi and then you open up a browser and you type in the IP address 192.168.0.1 or 192.168.1.1. And basically, after you do all of that, it's going to take you to a login page for the router. You're going to enter your admin username and password. And this information is usually written on a sticker or it's in a manual or it's somewhere out there on the wild internets, especially if you haven't changed any of the default username and passwords. And once you log in, then you want to go in there and start changing the default passwords, all right? And then after you do all of that, then you want to commence to configuring your DHCP settings. So you want to make sure that DHCP is enabled so that way your router can dish out IP addresses to all the random devices in your network. You want to set the range from anywhere between like .100 to .200. You could change that to make it fit your lifestyle however you want. And then as an option, you want to reserve IPs for specific devices. So if you got a printer up in your residence or your office, or you got some type of network attached storage up in there, you want to go ahead and try to give them a specific IP address that does not change or a static IP address. Then the next thing you're going to want to do is set up your Wi-Fi. So you want to give your Wi-Fi network a name, and that's also known as the SSID or the service set identifier. You want to use the WPA2 or WPA3 encryption, and you want to set a strong passphrase. After that, you want to assign static IPs like I said earlier. So go out there and give your printer, your file server, or whatever device a static IP by taking it off of DHCP. But remember, if you do that, you have to manually input all of the IP configurations that we talked about earlier. And then you want to go out there and test your devices. So you do that by restarting your devices so that they can get a fresh IP from the DHCP. You want to check each device's IP, subnet mask, gateway, DNS if you manually configured anything. And then after you do all of that, you want to verify functionality by browsing the internet or printing something off from your network printer. Now, for those of you who are out there in the field or you're looking to get a job, here are some common troubleshooting scenarios that you're more than likely going to find yourself in. So more than likely, you're going to have somebody call you and say that they cannot get on the internet. So the first thing that you're going to want to do is check the IP address. And if the IP address looks like this right here, where it starts off with 169.254, then that means that the device has failed to get an IP address, and you're going to want to go check your DHCP settings or your cable or Wi-Fi connections. After that, you're going to go want to check the gateway. So you want to make sure that the device has a gateway that has been assigned, because no gateway means no internet. Then after you check all of that, you want to reboot your devices. So restart the modem, the router, and the client device. And then after that, you want to go into the command prompt. You want to type in the command ipconfig release or ipconfig renew in order to get a fresh set of IPs getting sent off to your devices. All right, so let me go ahead and wrap all this wonderful information up. Setting up a SOHO network, this does not have to feel like you're decoding the matrix. Once you get familiar with IP addressing, whether it's IP version 4 or IP version 6, static or dynamic, private or public, you're going to realize it's more like setting up a well-organized digital neighborhood. Now, just remember, DHCP, this handles most of the grunt work. Static IPs, these are for devices that need to be found reliably. APIPA, that means it's a red flag. Subnet masks, these help define who is local to the network. And your default gateway, this is your road or your exit point to the internet. So whether you're studying for the CompTIA A+ or you're just leveling up your tech skills at home, understanding these concepts, this will set you up for success. All right, so with all that being said, let's do some check on learning. So our first question is, which of the following IP addresses is considered a private IP version 4 address? Is it 8.8.8.8? Is it 192.168.1.25? Is it 169.254.10.5? Or is it 216.58.212.14? And the correct answer is 192.168.1.25. So private IP version 4 addresses, these are reserved for internal network use and are not routable on the internet. And the 192.168.x.x, this is one of the designated private IP address ranges. Option A and D, these are public IP addresses. And option C, that is an APIPA address, not a private IP address. Next question. You notice that a device on your network has an IP address of 169.254.100.10. What does this indicate? Is it the device is using a static IP? Is it the device successfully received a DHCP lease? Is it the device is configured with an IP version 6 address? Or is it the device failed to contact the DHCP server and is using APIPA? And of course, the answer is going to be the device failed to contact the DHCP server and is using APIPA. So an IP address in the range of 169.254.x.x, this is an automatic private IP address, also known as APIPA. This means the device was unable to reach a DHCP server, so it assigned itself a fallback address for local only communication. And our final question is, what is the purpose of the default gateway in a SOHO network? Is it assigns IP addresses to devices on the network? Is it filters out unauthorized network traffic? Is it provides DNS resolution for internet addresses? Or is it routes traffic from the local network to the internet? And the correct answer is it routes traffic from the local network to the internet. So the default gateway, this is typically the router's IP address on the local network. It acts as the exit point for any traffic that needs to leave the local network and reach external destinations like websites on the internet.